Alright guys, welcome to geometry. Really welcome to Algebra 1. Let's give you a little review on here. You can already tell I don't like the quality of the screen on here. We're talking about reviewing radicals. I'm not here today, sorry about that, but looking at square roots and radicals and simplifying them. And there's three rules I want you to know. And here's a picture of Snooki, who got arrested for violating some radical rules on here by not simplifying something like that. So we're going to talk about three rules today, and the real context of this. This is not on your notes today, but I want to just talk about these three situations here. Anytime you see a radical, sorry, I'm trying to adjust this, that's not simplified, there's three ways to deal with it. One way, and these are all the same number on there, rad 12, not 12, rad 12. One way to deal with it is you can just call it irrational, and then do nothing else with it. You should have learned that now for one. It sort of just says it's a crazy decimal that you can't get it exact on there. Another way to do it is to type it in the calculator and approximate it. And it's square root of 12 is approximately 3.4641, blah 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 blah, and it goes on and on and on and on forever, which is why we call it irrational. And this is the practical way to do it. Later on in the year, and I've got a picture of a construction guy on there. Later on in the year, you'll have a word problems that you'll be dealing with. We definitely want to round it off to get an idea of how big that is. The third option is to simplify, and by simplify they mean get the number inside the radical as small as possible. So I could change that 12 down to a 3 by factoring the 12. Think of the 12 as a factors of 4 and 3. And if you had the square root of 4 times the square root of 3, you could simplify the square root of 4. The square root of 4 is 2. The 2 would come outside the radical. So there's three different ways of dealing with this. We're focused on this one. We're focused on the sort of the math geek version of how to deal with radicals. So that's one way we're going to talk about in terms of simplifying radicals. You should definitely know your perfect squares up through, it says on the screen up here, up to 25. On your paper, just write them down through 16. So real quickly, 1 squared is 1, 2 squared 4, 9, 16, 25, 36, 49, 64. And then keep going. You should be able to get beyond that. You should be able to get all the way up to 16 on there. 81, 100, 121, 144. And you really should be familiar with these. Certainly 225 is one you should know. These are almost the same thing. They're just numbers transposed. 196 and 169. 13 squared and 14 squared. And then 256. The reason I have these up here is because you might see these later on. And these might come up in the radical and you might want to recognize they can be simplified quickly. You don't have to worry about through 25 for now. I'll skip those. Next little thing I want to mention on here is just sort of inverse operations or opposite operations. The opposite of multiplication, of course, is division. The opposite of squaring a number, there's two names for it, is this little symbol here, which is either a square root, so you can either say that's a square root, or taking a radical. You'll often hear me say rad 289 or rad 242, radical 125. It's the same thing as saying square root of 125. So the opposite of squaring a number, opposite of multiplying a number by itself, is sort of like, and this symbol sort of looks like division, is sort of like dividing a number by itself to figure it out, sort of. Not exactly, but. So I'll get three rules I'm going to talk about on your paper. I've already sort of mentioned this one. When we say simplify a radical, one of the things we mean is none of the factors of this number inside the radical can be perfect squares. In other words, if you see this number inside of here as a perfect square, like if this was a square root of 25, you would simplify that to 5. It just so happens that 289 is 17 times 17. So if you were to see square root of 289, you'd factor it into its roots. That's why I've got this picture of a tree with roots on it, so to speak. And you break it down, if possible, to a perfect square factor. The rest of these you can't simplify. You can't get rid of the radical sign completely. So the square root of 242, hopefully one way you factor is you look at a number and you say, oh, if it's an even number, then 2 goes into it. What's half of 242? And hopefully go, yeah, 121. And then I'd ask you, if I was in class, I'd say, which one of these simplifies? And hopefully somebody would go, oh, 121. 121 is 11 times 11. So that 11 is really under a radical. The 11 becomes 11. Sorry, the 121 becomes 11, because the square root of 121 is 11. And this 2 is still sort of trapped underneath the radical. So if there's a perfect square factor of this number, that factor can come out of the radical and be simplified. If you were to do 11 times rad 2, it's the same thing as whatever this is in the calculator. And the same thing on these last two here. If you think of factors of anything that ends in a 5, I would at least go, oh, well, I know 5 goes into it. 5 quarters is a, is $1.25. Which one of these simplifies? Well, you go, yeah, square root of 25 is 5. So this becomes a 5 on the outside of the radical, and this 5 is still trapped underneath. Anything that ends in a 0, hopefully you're thinking it's factors of 10. And if it ends in 2 zeros, nice perfect square factors of 100. The square root of 100 is 10, so this 10 comes out, and the 7 stays in there. So you always want to come up with, think of, or hopefully come up with those perfect square factors that you wrote down on the top of your page. If any of those numbers, if 9 is a factor of a number, it can simplify down to 3 rad something. If 16 is a factor of a number, it can simplify down to 4 rad something. So you're welcome to work ahead if you want and just blast through this. I'm going to pause this thing and do this on part 2, but you can certainly try these. If you know how to do them, go for it and just check in the next section.